So here I'm in Mr. Chippy's workshop on bench 5B, because this is usually supposed to be a spare bit of space, but I seem to have commandeered it. And what I've done is connected my 7 meg 1964 Practical Wireless Project transceiver to our little solid state amplifier, and also that's so we don't have to use headphones. I didn't have that when I last used this. They got it connected to the Hewlett-Packard signal generator that we have in here, and then I've put the power supply precariously balanced up there because the lead isn't any longer. I wasn't intending it to be up in the air like that when I built it in the early 80s. So what I've determined is that it is receiving, but it's a lousy 7 dBm plus 7. And if I get my chart, because I don't know what they are, I work in microvolts. If we look at the chart, plus 7 is a tremendously deaf 500 millivolts to pick anything up. So it's as deaf as a post, but it is receiving. So I don't know why that is, and that's something which I will have to look into. I won't be able to really do that on camera. So I've made sure I've got one of those charts. I've laminated the circuit diagram so that I don't get my grubby paws on it. And so we're looking at this to the right, and first of all I'll just move the camera, and I'm sorry if we've got the background music here, because I've said a million times we have a 20 odd speaker background music system, and there's all kinds of things go over that, like the communication system and even the doorbell to the premises. So it goes through all the house, workshops, outside, you name it. And in fact, one of the amplifiers is right above my head, precariously mounted on a piece of wood. So in fact, I'll just move the camera onto that. So that's one of the 2 amplifiers we have for the public address system here, which, as I say, goes through 20 odd speakers. And this is a TOA amplifier, and this kind of feeds the outside. The other one feeds the house, this one feeds workshops, absolutely everything outside. So we have 2, and what's unusual about that, it is a line level amplifier. This is a 100 volt line system, and so you put a 100 volts line in, and it simply is a 240 watt amplifier to support umpteen 100 volt line speakers. Perhaps we need to do a video about public address systems and 100 volt lines, but there you go. Show's over. So with this level of deafness, I would think there's a component malfunction somewhere. But of course I don't know what the sensitivity was when I built it, because back then, you know, I built it and it worked, and by just putting in aerial links. I don't know what the sensitivity was, because we didn't have a signal generator that did 7 megs. So, you know, it was a bit like the article in 1964 that you didn't have any test equipment as such. We had the voltmeters and things, but certainly back then I certainly didn't have things like that synthesized signal generator, which it's now hooked up to. So I'm just going to sit there, and we'll just see if we can just do a little bit of a tune-up and just bring it up a little bit. So I can only just hear this. If I put this speaker amplifier, there's always a knot in something, isn't there? I've pinched this off Mr. Chippy's bench because he fixes guitar amplifiers. So if I bring this right up to the microphone, you may just be able to hear the tone. So I'm just going to see whether we can set the trimmers in here better. It's always a possibility. I'm doing this by ear. I mean, at this level, it's so deaf I don't need to put instruments on it. that's actually brought that up a fraction. What I don't want to do is to put 250 volts up my finger. Well, that's brought it up a bit. I might be able to knock the signal generator down. Yep, I can now hear that at plus 2 millivolts. So we'll do the first one again. See if we need to use the ceramic trimmer. See where we are now with that sensitivity. Wow. We're now in microvolts. So that's about S9 equivalent now. So I'll just see whether altering the green coil will make any difference. So a few weeks later, from doing the receiver on my homebrew 7 megs CW only transceiver, it seems to be producing RF, but it's not coming out. So I thought I'll look at, I'll just turn the tannoy down in this room. I thought I'll look at the everything that is about it. And do you know what? I've made this output coil. So when we look at the blurb, they've made theirs look much more compact. We've got L3 here, L3. My L3 is there, and it says 25 turns of 26 standard wire gauge enamel wire on a 3/4 inch diameter ceramic former, then 3 turns overwound at the end there as a coupling. So there's two things which I'd like to do. First of all, we're going to remake this. I don't know whether I put a sliver of paper around first so you can actually move the coil, but I'd certainly like to be able to move that overwind so we can find an optimum place for its coupling. So I got the steel rule out, and in millimeters that's about 15 millimeter, and in inches it is 5/8 of an inch. It isn't 3/4 of an inch. So I've ordered off eBay, rather than a pile of it from RS, some Perspex rod, and this is 3/4 of an inch. So I ordered it as metric, I think it's 20 millimeter, but it is 3/4 of an inch. So we're going to make a brand new one of those, and hopefully that will then work properly. Because I don't think it's been producing 12 watts, it's been drawing enough current to produce that kind of power. But I think it's only been about 1 watt coming out of the spout. I've had some contacts on it in the past, don't get me wrong, but I knew it wasn't right. And I think it thrashes the output valve. So that's what we're going to do. So I'm going to cut that to length, and we'll set about. The way this is done, the way I did this was to put some tagged screws into it, and I think that's the way to do it. So the trouble is, have I got the screws to go all the way through that? Because I've obviously got to go, they've got to be 1 inch long to I mean, nuts and bolts by screws, and preferably it needs to be I would think 6BA, okay, unless we do it metric. We'll see what we've got anyway. Okay, so we've got the HMV stereo master in the kitchen because there's nowhere else to put it, on soak test, waiting for the customer to collect that. What's that memory card for? I don't know what I'm doing here. I know what I am doing. I know what we're about to do. I don't know whether I'm using the same camcorder that I did the previous takes on, because we were wanting to make this replacement coil, and so I've got the parts in to do it, hopefully. Couldn't even find the junior saw, so I ordered one of those from RS. Oh my goodness. There we are, a real thing, an Eclipse one. Hope it's made in Sheffield. So because I want to make this a lot like I made the previous one, insofar as I want it to have connections on it rather than wires just draping off it. So to that end, and this is what the delay's been, I needed some longer screws, which are M3. So what we're going to do is we're going to drill this rod so that I can put 2 of these in at each end. So I will get some drills, and hopefully that's not flat, and we'll set about drilling this. Right, so we've got the drills. Might be useful to use Mr. Chippy's clamp-on vise. I don't know whether it will or whether it won't, but we can give it a go. I mean, really, I ought to go into the organ workshop and use the engineer's bench and do it properly in inverted commas. Now, my woodwork teacher at school in Rotherham, at Oakwood School on Moorgate Road before they pulled it down, said to me a useful phrase. He said, as long as you can, for as long as you can. And what he meant by that is keep the workpiece as long as you can, because it's easier to work on when it's this length than when I've chopped it to that length. So that's what we're going to do. It was Mr. Forthrop. It's amazing what you remember when you get older. Okay, so being an organ builder, we're bound to have imperial drills. So we'll start with 1/8 of an inch because that's usually 3mm. So if I put this one at the end, then if I move that round 90 degrees, right, that's 3 drilled. Okay, so we've drilled those 4 holes and now we're going to fit the screws through with solder tags. Trouble with these kits is they get assorted in transit. I get a huge amount of enjoyment on building stuff from scratch, so as opposed from a kit. And of course, a kit's better than a bought item insofar as what you're learning. But when you're actually having to source all the parts, and like this, it's a 1964 project, it all makes things harder to do. When my late mother was alive, I built her a valve radio, which was a 1961 or 1960 practical wires project, and you know, it worked great. But I tell you what, I don't think there's any change out of £150 for a medium wave only radio. But she did enjoy that, and it glowed in the dark, and like valve radios do. And I've forgotten what I was telling you. What on earth was I telling you? No, it's totally gone. It might come to me in the next 3 months as to what I was telling you. Right, we'll just tighten those up. I'll use one of Mr. Chippy's screwdrivers that I'm not allowed to touch. Nobody will tell him. Have we got any spanners, or is it hold it with the screw with the pliers? pliers. There, right, and I put it back before he notices. So there we are, we've now got our rod with solder tags. I'll just make sure they're pulled away a bit. And again, we've got this full length, so when we start winding the wire onto it, it's going to make things that bit easier. And that's what we're going to do right now. I bought a 1954 Heathkit AT1 off eBay, and it sold to me as not working and incomplete. We're currently having a transformer specially wound for that. I've got our big valve tester out. You've seen us test valves before. We've got one of those, who made them? Supreme America, it's the American brand, Supreme. I177 valve testers, and the MX949 expansion box, so it does newer valves as well. I've had one of those a long time, and so it does, you know, it's a World War II type of thing, and so it does World War II and earlier valves, and a few later ones as well. And when I opened up the heat, I'm going to have to do a video on this, I'll do a show and tell. We found that the 3 valves which are in this Heathkit, only one of them is the right valve. So, you know, you look at the pictures on eBay, don't you, and then suddenly you discover, in actual fact, you actually have to fork out for 2 valves. But I mean, the vendor wouldn't know, so that's how it is. But what I'm going to, instead of using our I177 valve tester, and we've got a newer American one as well, one of those really simplistic ones, I thought we'd dig out our Mullard high-speed valve tester. I don't know whether you've ever seen one of those. I'm just going to swing the camera around. So with the Mullard high-speed valve tester, which looks like an ECT machine out of a 1950s hospital, you have punch cards. You look up your valve type, you select the punch card, and you pop that in the slot, and you pull that down like a fruit machine, and instantly cathode ray tube display tells you your results. And it's either going to be, well, you've got a red zone which is going to be replaced, you've got an amber zone which is the kind of a bit neither here nor there, and then you've got the green zone. So that's how they blow me, I gets this out, and you've got setup cards, so you set up the you self-test it, in other words, with 3 different punch cards. So we've got the mains test, that's spot on, got the high tension test, spot on, then you've got the comparator test. Of course it doesn't work, does it? So that's going to be quite a job, because, well, I've just ordered complete new capacitors because in 1952, and that's what's going to be wrong with it. And what's kind of ironic, there's about 7 valves in there, so you need a valve tester to test the valves. Never ends. Anyway, back to the job in hand. I went and left my piece of paper, didn't I? What a fool. Here's a second-hand piece of paper. My sister once said to me, and she was living in Reading, and she's now living in York. She once said to me, no wonder you've got no money. She says, buying this posh sellotape. So if I didn't use a dispenser, I dread to think how we'd end up. So I've done that so we can, I just think it's the right way to do it. Theoretically, I'd say so we can move it around, but we're not going to be able to move it around because of the nuts and bolts. So what does it say here? 25 turns of 26 standard wire gauge enamel copper wire on a 3/4 inch diameter ceramic former. And then 3 turns wound over the end as a coupling. I'm not sure how we did the other one. I might have to I might have to think about that. Yeah, it looks like so 26 SWG. Should be 0.45 millimeter. This is something we've worked out before we ordered this. If this doesn't work, I'll be getting back on the calculator. Changes glasses. I can't find where the end is. Yeah, they've hooked it through. So we'll hook that through one end. I'll get rid of that nasty bit. And just for now, we'll just wrap that round there rather than solder it. So it's 25 turns. That's 20. Oops, crossed over there. I'll just neaten this up. "21, 22, 23, 24, 25, Right, and then it says 3 over the end of the wiring as a coupling. So once again I'm going to put some paper around this so that I can slide that coupling. And this time I can put that around there. And tape that, and then we'll put the coupling on, and that's hopefully loose enough that I can move it up and down so that I can get my best output. I'll solder these on. I've scraped the insulation off. So the next winding is 3. Tell you what, it'd be easier to get rid of the insulation first on the start. If your soldering iron's hot enough, it'll melt through this stuff anyway. Okay. One, two, three. I know what I was telling you about the valve radio I made for my mum. It needed a radio frequency choke, and in those days Denko were about at Clacton-on-Sea doing some really nice chokes and coils and things. Of course, they've long gone. And even when I was building this in the 90s for my mum, so I looked back in the 1930s practical wireless, which was a time when you actually had to make your own parts, and I found the instructions on how to make your own radio frequency choke. And so it started off, they were doing it in wood, I think, but I bought some tough knoll from RS, and then on my lathe in the organ workshop I think we had to put 10 compartments and wrap something ridiculous like 150 turns of wire in each of the 10 compartments. And I did that, and I did I did one of these compartments of wire per evening. So I did 150 turns of wire per evening because I just couldn't do that forever. It's not like I've got a coil winding machine. And so at the end of 10 days, I'd finished it. And I put our LCR meter on it. And it was more or less the right number of Henrys. It was supposed to be 5 millihenries or 5 Henrys, I can't remember. Anyway, work to treat. So that's a time when using a 1932 issue of Practical Wireless can be very, very useful. You see, we're back to that here, aren't we? Making a component. Not buying a component, we're actually having to make it. Having mismade it the first time. I'm going to leave the wire long on that so I know it's the overwind, although I can see it's the overwind. So we'll just check these for continuity. Mr. Chippy has an expensive analog meter. Yep. And the other one, yeah, fine. I think we'll bring the little vise back. Bet this would be dead easy to cut if I've just got a hot wire. We'll cut it there. Right, we'll wind that back on the reel and take the kink out of it. I think we'll put some sellotape on the end. Right, I'll go and get the... So I've taken the old clip out, which was to support the old coil, and I've bought a conduit clip, 20mm, 15mm, which hopefully will be the right for that. So I now need to drill a bigger hole because it obviously needs a bigger mounting screw. Just tip the burr out of that. Okay, so we've now got that coil in its holder. Of course, it's not in the same position because it would have been pushing against the valves, and they, of course, get very hot. So we're going to try it in that position, and the next thing I'm going to do is we'll power it up and we'll see whether we're getting any RF into the meter. Now, the way it worked before didn't work. Instead of doing about 4 to 12 watts, whatever it's supposed to do, it was doing about 1 watt, and then I was using a small linear amplifier to bring it up to about 15. So I did use it, but of course it wasn't right and it wanted addressing. And it's amazing. I said to Mr. Chippy, what on earth's wrong with this? I've checked the wiring. And he says, well, that coil's the wrong diameter. You know, second pair of eyes and straight away. So let's see whether it's going to work a bit better. Okay, so I thought we were going to be there. So we've installed the coil and we've connected it all up, and I've still got no proper power output. And I'm just wondering if, with the coil being made wrongly, as I said in the beginning of this video, or earlier in the video, I wonder if the valve's been thrashed and it's now no good. Well, I can't test it on our valve tester, so what I've done is to order a valve. So we'll see what happens. So we'll bring this to a close at this time. We actually started the receive part of this video in January. It's now May, so it's about time to move on. So we haven't finished it. It still needs to be I think we have done it, but I just think the valve has been damaged. So we'll take a break at that point, and that's as far as this goes for the time being. So we'll get it sorted out. We'll come back to a video in the future. So when you see this, we'll have done the receive, which was greatly improved to, I think I got it to 1 microvolt. Bearing in mind it's a regenerative receiver, it's not super het, and it just uses the one valve. So there you have it. That's the 7 megs as far as we've got it at the moment.